Hello everyone. In this video we will learn about symmetric matrix, skew symmetric matrix, their properties and also the representation of a square matrix as the sum of a symmetric matrix and a skew symmetric matrix. First we learn about the symmetric matrix. Any of the square matrix such that its elements follow a rule, that is Aij equal to Aji, is known as a symmetric matrix. A square matrix such that its elements are Aij equal to Aji is a symmetric matrix. Let's take one of the examples. Suppose we have a matrix A. The elements in this are A, B, C, D, D, E, E, F and F. What we find here, this is a matrix of order 3 into 3. And we find here this A12 is same as A21, that is equal to D. A13 is equal to A31, that is equal to E. And A23 is same as A32, that is F. It means this is a symmetric matrix. One more thing we see here, if we find the transpose of A, that is A, D, E, D, B, F, E, F, C. We find this is same as A. It means for any of the symmetric matrix, we find that the transpose of the matrix is the matrix itself. So we can also say if a square matrix A is such that AT is equal to A, then A is a symmetric matrix. Now a skew symmetric matrix, it is also a square matrix. In this the elements follow the rule that Aij is equal to minus Aji. A square matrix in which the elements are such that Aij is equal to minus Aji is a skew symmetric matrix. Let's take one example here. Suppose we have a matrix B and the elements in this are P minus P, Q minus Q minus R and R. What we find here? We are finding A12 is minus A21. A13 is equal to minus A31. And A23 is equal to minus A32. So it is a skew symmetric matrix. If we go for the transpose of B, that will be here 0 PQ minus P 0 minus R minus Q R and 0. What we see here, that is not equal to B. But if we take minus common, it will be 0 PQ minus P 0 minus R and minus Q R and 0, which is equal to B. It means we can say that the transpose of the skew symmetric matrix is equal to minus of it. So we can say that if a square matrix X is such that xt is equal to minus x, then X is a skew symmetric matrix. Now we have to think that every element of the main diagonal here is 0. Why it is so? Let's learn it. See the property of the elements, it is aij equal to minus aji. If I and j are equal, it means aii is equal to minus aii. It means we can say aii plus aii is equal to 0 or 2aii is equal to 0. It means aii is equal to 0. That shows that every diagonal element of a skew symmetric matrix is 0. So this we have to remember that every element of main diagonal of a skew symmetric matrix is 0. If it is not, then it can't be a skew symmetric matrix. Let's learn about some of the properties or theorems based on the symmetric and skew symmetric matrices now. Suppose A is a square matrix, then the first theorem or property is that A plus AT, or we say A plus A dash, is a symmetric matrix. We can also write this as A plus A dash. For the proof of this theorem, what we do, we consider that A plus A dash is equal to P. Then we know that any of the square matrix is symmetric if its transpose is equal to itself. It means here if we are able to show that the transpose of P is equal to P, then we can say it is symmetric matrix. We go for P dash, that is transpose of P. Will that be equal to the transpose of A plus A dash? If we go for the property, that will be A dash plus A dash dash or not, because we know that A plus B dash is equal to A dash plus B dash. We can also write this as A dash plus A. Why? Because we know that the transpose of a matrix is equal to itself. Can we also write this as A plus A dash? Why? Because we know that A plus B is equal to B plus A. Addition of matrices is commutative. And this is equal to P. So we can write, since P dash is equal to P, this implies that P, that is A plus A dash or A plus AT, is a symmetric matrix. From this particular thing, we can also say that half of A plus A dash is also symmetric matrix. Why? Because if we divide by 2, it makes no difference to the property that it will be symmetric. The second property or theorem for a square matrix A is that A minus A dash is skew symmetric matrix. For the proof of it, we consider that A minus A dash suppose is equal to Q. Then we find Q dash. Q dash will be dash of A minus A dash, that is transpose of A minus A dash. We can write this as A dash minus A dash dash, because we know that the transpose of A minus B is equal to transpose of A minus transpose of B. We can also write this as A dash minus A, because we know that the transpose of A is A. If we take minus common from this, we will get minus A dash plus A, or we can write this as A minus A dash. This is Q. It means this is equal to minus Q. And we know that if the transpose of any of the matrix is equal to the negative of it, then this is a skew symmetric matrix. It means we can say that Q that is A minus A dash is a skew symmetric matrix. Also we can say that half of A minus A dash is skew symmetric. The same problems for property of theorem number 1 and 2 can be asked to you when A is given in the numerical form. You have to find the transpose of it and then we can prove that it is symmetric or skew symmetric. The third property is that a square matrix A can be represented as the sum of a symmetric and a skew symmetric matrix. Let's see how it is. Suppose we have a square matrix A. Can we write A as half of 2A? We multiply and divide by 2. Can we also write this as half of A plus A? If we add A dash and subtract A dash in this will be half of A plus A dash plus A minus A dash. We can also write this as half of A plus A dash plus half of A minus A dash. This can be taken as X and this as Y. And we have just now learnt in property 1 and 2 that half of A plus A dash is symmetric and half of A minus A dash is skew symmetric. So we can say that any of the square matrix can be represented as the sum of a symmetric and a skew symmetric matrix, where X is a symmetric matrix and Y is a skew symmetric matrix. And let's take one of the example based on the third property, that is representing a matrix as the sum of a symmetric and skew symmetric matrix. And here it is, A is a matrix given to us. We have to find two matrices, one of which is symmetric, another is skew symmetric, and the sum of them is equal to A. For the solution, we take the square matrix which is given to us, that is A, and we find the transpose of it, A dash. A dash means interchanging the rows and the columns. So it is 2, 5, 7, 3, 8, 4, 1, 2, 6. Now we find A plus A dash. This is 2, 5, 7, 3, 8, 4, 1, 2, 6 plus 2, 3, 1, 5, 8, 2, 7, 4, 6. Which is equal to, adding the corresponding elements, this is 2 plus 2, 4, 5 plus 3, 8, 7 plus 1, 8, 3 plus 5, 8, 8 plus 8, 16, 4 plus 2, 6, 1 plus 7, 8, 2 plus 4, 6, and 6 plus 6, 12. We can find half of A plus A dash. That will be half of the value of A dash we will write here, 8, 16, 6, 8, 6, 12. Every element is to be divided by 2, so it will be 2, 4, 4, 4, 8, 3, 4, 3, 6. Similarly, we find now A minus A dash, subtracting this. That is A 2, 5, 7, 3, 8, 4, 1, 2, 6 minus A dash 2, 3, 1, 5, 8, 2, 7, 4, 6. Subtract the corresponding elements, we get 2 minus 2, 0, 5 minus 3, 2, 7 minus 1, 6. 3 minus 5 minus 2, 8 minus 8, 0, 4 minus 2, 2. 1 minus 7 minus 6, 2 minus 4 minus 2 and 6 minus 6 is 0. Now we can find out half of a minus a dash. That is equal to half of 0, 2, 6 minus 2, 0, 2 minus 6 minus 2, 0. And that is divide each element by 2. 0, 1, 3 minus 1, 0, 1 minus 3 minus 1, 0. Now we consider that half of a plus a dash is suppose p and half of a minus a dash is q. Now we will find out p dash and we find here p dash is 2, 4, 4, 4, 8, 3, 4, 3, 6 which is equal to p, which implies that p is a symmetric matrix. Now we find q dash, and q dash we can say here will be 0, 1, 3 minus 1, 0, 1 and minus 3 minus 1, 0. If we take minus common from this, this will be 0, 1, 3 minus 1, 0, 1 minus 3 minus 1, 0. We find this is same as this. It means this is equal to minus q. And we know if q dash is equal to minus q, this implies that q is a skew symmetric matrix. Now we can write, we know that a can be written as half of a plus a dash plus half of a minus a dash, which is equal to p plus q. We write here the value of p, that is 2, 4, 4, 4, 8, 3, 4, 3, 6 plus q. Q is 0, 1, 3 minus 1, 0, 1 minus 3 minus 1, 0. It means now A has been represented as the sum of a symmetric and skew symmetric matrix. If we find the sum of this, is that equal to 2, 5, 7, 3, 8, 4, 1, 2 and 6. This is same as A. Like this we can represent any of the square matrix as the sum of a symmetric and skew symmetric matrix. So this is the answer to this. In the next video we will learn about the elementary transformations or elementary operations on the matrices. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.